So in this video, we're going to look at some different distributions, and the names of them, and then kind of the characteristics of these. So let's start with a uniform distribution. And a uniform distribution is when each bar on the histogram, or each class, has around the same value. And so in this case, they're all around 12. And so this would be a uniform distribution. We'll look at what some non-uniform distributions look like. But this one, if it's perfectly uniform, they'd all be the same. In this case, they're really close to being the same. They're all around 12. And so this might be something where if you roll some dice, or rolling a die, if you look at the outcomes of rolling a die, this would, the numbers on that chart are not indicative of that, because if you look at the X labels, that doesn't work for dice because it only goes up to 6. But if you think about, rolling a die and then tallying what those answers were, if you did 1, 2, 3, 4, 5, 6, they would all be about the same height. If you rolled it 100 times, each of those would be about 1/6 of 100, so around 16. That would be something where it would look uniform. And then for each of these, we're going to talk about, well, what would be the best description of the center? We talk about the mean, the median, or the mode. And so with this one, really none of them are a good description of the center. And the reason why is because, the outcomes on the far right and far left are just as likely as in the middle. So finding the middle really doesn't really tell us a whole lot about the data. And if you think about dice, the average would be around 3.5. Well, you can't roll a 3.5. And the, 3 being the middle, or 4 being around the middle, that doesn't mean that that's any more likely than a 1 or a 6. So rolling dice is all the same outcome. So there really wouldn't be a good mean, median, or mode to use with a uniform distribution. For a symmetric distribution, though, down below there, this one is where you've got a middle, just right around there where my arrow is, and it's about the same on the left and the right. I mean, this one is, it's got a little bit of a tail here on the left, but really not much. We'll see one with a big tail in a moment here. And so here, the mean is going to be in the middle, along with the median and the mode. So really, any of them would be a good description of the center. You could use the mean, the median, or the mode. Mean, median, or mode. Another example, and this is one that I don't have on here, but we can just talk about real briefly, is if you are doing categorical data, like, if you opened up a package of M&Ms and you recorded the colors, that would be, you would want to use mode because you can't do mean or median to describe the average of colors. That just wouldn't work. Or you could say none. But anyway, back to symmetric. So the middle is always going to be the same for the mean, median, and mode. And if it's not identical, it'd be pretty darn close. They'd be about the same. Because that's where the most happens, that's where the middle is, and that's, if you average it all up, it'd be around there as well. Okay, on a skewed left, so in a skewed left distribution, the left tells us where the tail is located on the graph. And I'll explain why it's called skewed left in a moment here. But if you look here, the mode is where that green arrow is pointing. And then what happens is when you've got a tail to the left, the median's going to be shifted just a little bit. So let me write that, median. But all of these values down here at the bottom are really going to pull the mode down toward that tail. And so what happens is the mode gets, or sorry, that's wrong. I said mode. It's not mode, it's mean. My fault, sorry about that. This is the mean. So let's explain that. The mean is going to be pulled toward that tail. All those values on the left are going to pull the average down. And another way, if you're ever kind of thinking about this, like, let's say you took the average salary, so how much money people make, and you have 30 people, but of those 30 people, most of them make around the same. They're all kind of normal jobs, but then one of those 30 people ends up, being a billionaire. Well, the average is going to be really high because one of those people makes $1 billion, and so they're going to say that the average is much higher than what people usually make, but because that one is pulling the mean up high because of that high number. And so you just think of like an extreme case where somebody makes $1 billion, that's going to affect the mean, but it's not going to affect the median because the middle number isn't going to be affected by some gigantic outlier like that. Okay, so as far as what would be the best description of the center, the mean is skewed because of that tail. So the mean is getting pulled down. So I would say the median is going to be the best description of the center. The mode, not necessarily. That's just the tallest bar. But the median would be really about where you would say the center of the data is located. And same thing with the skewed right distribution. So the mode would be this red line. That's the tallest. The median is going to be right in that middle range, and then the, mean is going to be pulled toward the tail. So because we have this tail off to the right, that's going to skew the mean to the right. And the best description of the center for this is also median. So it says in a skewed distribution, the blank is pulled blank. And so what we've noticed is that the mean is pulled toward the tail of the graph. So when you have a skewed right distribution, the mean's going to be pulled to the right, or in a positive manner. If you have a skewed left distribution, the mean's going to be pulled down or to the left. All right, then last question here, just a quick see how we understand this stuff. Construct a data set where the median is 10 and the mode is 9. Well, what that means, no pun intended there, is that the median, being 10, is going to be in the middle. So you want the same number of numbers above 10 as there are below 10. So let's say we add a 9 down below, then we want to add something above there. And we want the mode to be 9, so I'm going to have a couple different 9s. So maybe I'll do a 13. 10 is still in the middle. Let's do another 9. We still want 10 in the middle, so let's just do a number above 13, so 17. So this would be a data set where 9 is the mode and 10 is the median, and you can just leave it like that. All right, so that is distributions. Hopefully that helps explain what those are. And then just one quick example tied to mean, median, and mode.